So I had a pretty solid 8-hour debug session across a couple of days, and I decided to do a retrospective and figure out what I could have done to get to the answer sooner. And the details won't interest you, but I thought some of the general conclusions might. And it was an interesting debugging story. So I'm using Platform IO to develop code for two different 8266 boards that you can see here. And they're slightly newer and older versions of a very old chip. Just take different size lithium-ion batteries there. And they have different amounts of flash. And I had never, I'd done some decent sized projects with Platform IO, I think, but I'd never touched the Wi-Fi so far. And when Peter last week or the week before talked about doing the over-the-air updating, I just had to try that because I'd only been doing serial updates up to that point. So I decided to look into it, and there was a lot for me to learn. And a key thing I didn't quite appreciate, I think Peter might have mentioned this, but it didn't really sink into me, is that there's no over-the-air upload support in the boot ROM for the ESP8266. So the only way you can get an over-the-air update into the card is through code that's running. Right, so it's like changing the wings on an airplane while you're flying almost. And the library which is used for this is called Arduino OTA. And the key thing to understand is that you have to do one final serial upload that has the code in it to allow future upload through Wi-Fi. And up to that point, you can't do anything with Wi-Fi. So the way I think about this graphically, just to give you background here, is that this is how I sort of visualize what's going on. I'm doing development on a box where I run this Platform IO host. It has a couple of things called ESP tool that talks USB serial, really talks serial over a USB port, and a thing called ESP OTA for over the air. That's a Python script, and it can speak Wi-Fi. So the idea here is that you're using the serial upload through this to talk to the ROM to get this Arduino OTA code loaded into the flash. Then it can listen to the Wi-Fi, and you can do all your future updates that way. So the key points is that really Wi-Fi is an afterthought from the point of view of the Arduino, I guess the whole framework, right? And the ROM over here only listens to what's coming in on serial. And if you want to do Wi-Fi updates, then they have to be, code you add to your project that runs out of the flash. And Peter knows all this. I had to learn that after his talk last week. So the odd symptoms were that OTA just worked great. I mean, it was running in like less than an hour on the development board I had with 4 mega flash, which was the newer ESP8266 chip. But it failed in a strange way on the slightly older ESP8266 that had only 2 mega flash. And I thought, well, maybe 2 megas is not enough. And this is the error message I got. So it said flash config wrong. And I learned there's really kind of a missing comma there. Real, and this is 2 megabytes, and IDE 4 megabytes. So I thought this message was telling me is the board has 2 megabytes, but the IDE was configured for 4 megabytes, which kind of made sense because it worked when I used it with a 4 meg thing. And I knew the IDE needed to be configured with the size of the ROM so that it wouldn't even compile code that wouldn't fit and things like that. And I figured it could be a rookie mistake because flash sizes vary among boards. So I did some Googling and ran into what I know in retrospect is a red herring. This is a shot from the Platform IO documentation that shows the particular board I was working on, which I know has 2 mega RAM or 2 mega flash, showed 4. So this was a mistake in the doc. And so I spent a couple hours trying to figure out if that was real. Turns out it wasn't, and I had to dig through the source code of Platform IO and find that for the board I was using, the flash size really was 2 meg, and that was a dock problem. Because this is the code I was running. I mean, I took apart the actual IDE I was running, and I used a bunch of techniques I've used over and over again, like intentionally misspelling the name to make sure that it was actually parsing what I put in there. And I tried configuring it with 1 meg and 8 meg and other things. And in retrospect, there's an important clue I missed here, which was it was the same error message I was getting, no matter what I changed for the size. And that should have been a clue to me in retrospect. And I missed the fact that the changing the size didn't change the error message. So love Google, hate Google. Tried and true strategy is to Google the error message. So going back to that, bad flash size message, I Googled it and Googled it and Googled it. And what I bumped into was that Platform IO thing. It turns out that was an old version of the Platform IO doc. They'd updated the doc when they updated the code. I don't know if the code ever was wrong. The code might have been correct from the beginning. The doc was wrong. And Google led me to the old doc. And I think I've seen a bunch of other projects where they maintain URLs to the old, but they sort of replace with the latest stuff. And the old URL gets a banner across the top saying, you are reading legacy documentation. Here's a link to the current version, which I really appreciate when that sort of thing happens. So anyway, when I kept searching for that error message, I kept getting these error messages that were what I'd call poor matches. And I just kept, banging my head against the wall. I could see people had similar problems, but never a resolution. And that was frustrating. I went on and tried Platform IO on 2 different machines here, both Mac and Linux, same symptoms, right? So, and I knew that my symptoms were not common because I wasn't getting, good Google hits that had problems and solutions. But yet I did know this chip is widely used. So it couldn't be, that I got poor answers just because nobody asked the question. There had to be a small number of people even asking the question, and even smaller, and nobody getting an answer. So I finally figured out that I'd been reading the error message wrong. When this says flash config wrong, I thought that was the script I was running on my host, since that's what produced the error message. I thought that error message was coming from the script. It wasn't. So I looked in the way I figured this out was I looked through the source code for the script, and this flash config wrong string, which was in the error message, just appeared nowhere in the code I was running. So I went back and Googled more. Well, that was stupid. Eventually, I hit on the idea of tracing the Python code and figuring out where that was coming from. I thought maybe it was in a library or something. Here's the key insight. That error message was coming from the ESP8266. And really what the earlier part of this error message is telling me is that the Python code running on your host, Bob, asked a question of the code in the 8266, and here's what it told me. It told me the flash config was wrong. So this was not my development code, my IDE double checking the capabilities of the board. This was the board saying, I refuse to take what you built for me. So that was a giant insight. And here's that same thing sort of visually, right? I was looking at, what was running on my host and thought when I first read this error message that the error message said, I was trying to build something for your board, but I screwed up. And when I talked to your board, I discovered it wouldn't fit. But no, in fact, what happened is the IDE thought sure it had built something perfect for the board. It went to the board and said, here, take my thing. And the board said, I refuse. So I knew something, but I still didn't understand the problem. And I kept going back and trying on these other flash sizes. And, I didn't really make sense of why the IDE number didn't change, right? This number kept being the same no matter what I compiled it for. And that's what led me to my second key insight. The size mismatch wasn't between the host and the code in the board. It was between the code in the board and the board itself. So this wasn't a complaint that, I built the code wrong or the Platform IO didn't like it. It was a consistency check. And so it turns out that little bit of Arduino OTA code, I built it for 4 meg, downloaded it via serial. It found itself running on 4 meg and didn't do that consistency check until I tried to send something down over the air, and then it failed. So this was easily fixed. And in retrospect, what I should have done was gone back and tried one more upload via serial to solve the problem. But I didn't think to do that. So really what was going on, this error message was saying, this here that I sent down via serial was compiled for 4 meg. And it found itself on a 2 meg card. And so there's nothing I could have possibly sent over the air that it would have accepted. So no matter how I built it, I wasn't going to get anything accepted. What I need to do was one more last serial download with the thing built correctly, and then it would have worked. So in retrospect, what I found all this coming together is that, Platform IO has to be configured for the flash size, and configuring smaller hardware, has no net problem as long as you don't run over the limit. If you're not doing over the air, you can be a little sloppy about matching up the IDE with the card, right? You can build things a little too big, a little too small, and they still run as long as they fit. But as soon as you try and use this over the air thing, now you got to get it right. You got to get it right, the last serial download, and then all of the OTA downloads after that. So that's finally where I got to the solution here. And the wrong turns basically were, first I thought I had a bug in my IDE, and it turned out to just be a bad Google, Google the old doc. And then I thought I had the IDE detecting a config mistake I'd made, and no, it wasn't that. Finally, I thought it was the, over the air refusing to accept my build because there was something wrong with my build. And finally, I figured out that, it was the server code inside that over the air that was not built right in the first place. So happy ending, very quickly. As soon as I figured out what was going wrong, just one more flash serial upload, and it was fine. And I'll never make that mistake again. And I don't want to sound ungrateful to the people who managed to get over the air uploads possible on a machine with 80 KB of RAM. I mean, man, that's that's an accomplishment, and I'm super grateful for the work those people did. And I can also see some rationalization. So I'm not here to shake a finger at the authors of the OTA code or the host code, because a more elaborate error message would have been taking up very precious space in Flash. And there's a high cost to avoiding that runtime code. They don't want to do anything dynamically. They want it all pre-configured, so there's no branching happening on the board. So in retrospect, I think this could have been a little more clear, and I probably should submit a bug report, but I have not yet done that. And this perhaps could say error response from Arduino OTA. Right? So it was very clear that it was sort of quoting, whatever comes after this point is being quoted from some other piece of code, not the piece of code which is producing all these other error messages. This is just logging that's coming from the host side. So shame on me that I haven't yet filed a bug report, but I will. So Googling the error message is still a great strategy, but I need to be paying close attention to the quality, I guess you'd say, of the hits, right? And be ready to conclude that my problems are unusual, not just that I didn't Google hard enough, because that really changes things, is understanding how likely it is that you're running into a problem somebody else has run into, because then there's a solution out there. But if you're running into a problem that is only yours, you've got to take a different debugging tack completely. And, I should have been able to figure out just from the quantity. I mean, they're selling these boards for like less than $4 a piece. So they're just an enormous quantity, right? And these are the older ones even though it's an odd flash size, there's still just gobs and gobs of things out there. And people would have hit this problem if it was a common problem, and there'd be Google trails about it that I didn't find. And still, I think intentional misconfiguration is a great strategy for, getting to the bottom of, like where an error message is coming from. And is my configuration actually being parsed? And, does it do what it says on the tin? But I didn't go back and think hard enough about the negative results I got on some of that. And that's another lesson to me. And I guess another final lesson is that, whenever there's two pieces of code communicating, a client and a server, or in this case, a host IDE and then some download code, there's people who write error messages have a point of view in mind. And if me, the viewer of the error message, has a different point of view, then that's a disaster. And I should have been more prepared for that. And I also should have, my goal was to get over the air working. And so I just kept pounding on over the air. And even when it didn't work, what I should have done was gone back to serial. And that might have just dumb lucked me into it, because that would have pushed one good final update down there. So that's the last lesson learned, I think. Yep. Okay. Anyway, thanks again to Peter for figuring that out. Okay.
Well, that's great. That's that sounds like really good stuff to know. I don't know that I've run into that, but I think I could run into that, even though I use the Arduino IDE. I think the same problem would probably apply.
Yes, I think it would.
And
yeah, it's
the other thing that occurred to me is, along with filing a bug report, I wonder if there's anything you could do to get a Google trace out there, so that someone searching for the same problem would actually find their find their results on Google. I'm not sure how I'm not sure how one would go about doing that. But it would be, maybe that could save the next person from the same headache.
Yes. So I'm in that spot where I have a domain name, reserved as just a placeholder website there. I'm going to get a blog up where I can write things like that. And someday I'll post slides like this, which would have all the Google juice in them to get it there.
Yeah, but that'd be cool. Yeah.
Yeah,
these slides can be put on the Workshop 88 Dropbox, and they can be put in the. If you wanted to do a quick post, you could do something on the Workshop 88 blog. And
great idea.
This is going to make a great video.
All right. Well, and it reminds me too that Jim has the luxury of having a decade of blogging going on there, and all sorts of Google hits on those, I'm sure.
It's always funny when I'm looking for something and find it on my project notes. No, I don't.
Yeah, that's a good thing. You're writing to your future self.
Recently I also had a very similar experience with running into errors and Googling it, and I think 4 people on the entire internet had run into the same thing, sort of thing. And I'm like, well, I can't really be that unique, that sort of thing. That's just, I'm questioning the whole endeavor or whatever. And I can tell the story later because it's not super relevant, but it ended up being a path issue. And I was just like, and it was so bizarre because I checked it on one way and the path was fine. I checked it another way and the path was fine. And then the way that I was trying to merge the two together, it just wasn't right. So I don't know. But Googling it, like you're saying, it was just it should have come up with the correct hits, and just sometimes doesn't. So that's super frustrating. So I'm curious though on the, and this
and I think there's data in there though, Andrew. That was a key point I wanted to make. The fact that it should come up and doesn't is pay attention, Bob. This means your assumptions are wrong. Sorry,
true.
Go ahead.
I think you're right, and I think that's very much relevant to my situation too, because in the little things that I saw, people kept pointing to, well, you got to check your path, you got to set the path, and I'm just like, okay, but I've done that, and no, I hadn't done it right. So yeah, but I guess what I'm curious on, and this is not, it's relevant to your situation, to the OTA just in general. I am very curious about, I did a little bit of reading about putting these ESP8266s into like super low battery or super low power mode. And I'm curious about if you enable the OTA updates, does that, without other considerations of doing anything else to put it into low power mode, does that significantly change the power consumption just when it's in general sort of like standby use, or does it not?
As near as I can tell, no. I haven't done detailed measurements, but there would be some tricky interaction between over-the-air updates and the deep sleep modes.
Yeah,
you'd have to do it in such a way that in effect the model, or how do you say this, the model for serial uploads is the term they use, even though it feels to me like it ought to be down. But the model for serial uploads is the ROM is just sitting there waiting, right? And the host is just going to shove it in whenever the ROM says yes, I'll take it. So the serial uploads don't happen until the host starts them. And there's no way for a board to wake up and say to the host, may I please have a upload now? And what you're asking for in the case of the OTA with a deep sleep is, it wakes up for the first time on a Tuesday and says, oh, today's the day I check, and I'm going to put extra power into the Wi-Fi stack, and I'm going to, you know, go to a server somewhere. And the server's waiting for me. Right. And I'm going to say, may I please have my update? That's a completely different model than the board waiting for the host, but I'm sure it can be done. I think there's services that'll do it for you. Oh, in fact, Amazon will do it for you. That's, you know, these little orange boxes I bought from Amazon, you know, the reason Amazon is selling these things inexpensively and pushing them is because they want to get services revenue off of AWS. Mm-hmm. And they'd be thrilled to have an AWS server waiting for this thing to wake up and say, may I please have my update?
Cool. All right. Well, thank you so much for that debugging story. I loved it.